children, I am Ekta. Children, have you ever noticed triangles in everyday life? Triangles are all around us. Think about the shapes of traffic signs, the roofs of houses, or even the sails of boats. Each of these uses triangles because they are strong and stable shapes. In this lesson, we will learn about different parts of triangles like medians and altitudes. We will also explore special triangles like equilateral and isosceles triangles. By understanding these shapes, we can see how they are important in construction and design. Let's discover the amazing world of triangles together. Learning outcomes. After the completion of this lesson, you will be able to learn about the parts of a triangle, including medians, altitudes, and angles. Discover the special types of triangles, which are equilateral and isosceles. Understand how to use the exterior angle property in triangles. Apply the triangle inequality rule to check if side length can form a triangle. Keywords from this lesson are triangle, medians, altitudes, angles, equilateral, isosceles, exterior angles, centroid, interior angles. Children, in the previous video, we have seen types of triangles. Today, first, we are going to see some important parts of triangle. First, let us see medians of a triangle. Median is the line segment which made by joining any vertex of the triangle with the midpoint of its opposite side. Median divides the side into two equal parts. Every triangle has three medians like AE, CD and BF in the above triangle. The point where all the three medians intersect each other is called centroid. Altitudes of a triangle. Altitude is the line segment made by joining the vertex and the perpendicular to the opposite side. Altitude is the height if we take the opposite side as the base. The altitude form angle of 90 degree. There are three altitudes possible in a triangle. The point of intersection of all the three altitudes is called orthocenter. The exterior angle of a triangle. If we extend any side of the triangle, then we get an exterior angle. An exterior angle must form a linear pair with one of the interior angles of the triangle. There are only two exterior angles possible at each of the vertices. Here, angle 4 and angle 5 are the exterior angles of the vertex. But angle 6 is not the exterior angle as it is not adjacent to any of the interior angles of the triangle. Now, let us see exterior angle property of the triangle. An exterior angle of a triangle will always be equal to the sum of the two opposite interior angles of the triangle. Here, angle D is equal to angle A plus angle B. This is called the exterior angle property of a triangle. Let us see one example. Find the value of x. Solution: x is the exterior angle of the triangle and the two given angles are the opposite interior angles. Hence, x is equal to 64 degree plus 45 degree. X is equal to 109 degree. Angle sum property of a triangle. This property says that the sum of all the interior angles of a triangle is 180 degree. Measure of angle A plus measure of angle B plus measure of angle C is equal to 180 degree. Example: find the value of x and y in the given triangle. Solution: x plus 58 degree is equal to 180 degree, linear pair. X is equal to 180 degree minus 58 degree. X is equal to 122 degree. We can find the value of y by two properties. Angle sum property. (60° plus 58 degree plus y is equal to 180 degree.
118 degree plus y is equal to 180 degree. Y is equal to 180 degree minus 118 degree. Y is equal to 62 degree. Exterior angle property. X is equal to 60 degree plus y. (122 degree is equal to 60 degree plus y. Y is equal to 122 degree minus 60 degree. Y is equal to 62 degree. Children, now let us see two special triangles. Equilateral triangle. It is a triangle in which all the three sides and angles are equal. Isosceles triangle. It is a triangle in which two sides are equal and the base angles opposite to the equal sides are also equal. Sum of the length of the two sides of a triangle. Sum of the length of the two sides of a triangle will always be greater than the third side, whether it is an equilateral, isosceles or scalene triangle. AB plus BC greater than AC. AB plus AC greater than BC. AC plus BC greater than AB.
Example. Check whether it is possible to make a triangle using these measurements or not. 3 cm, 4 cm, 7 cm. We have to check whether the sum of two sides is greater than the third side or not. Four plus 7 is equal to 11. 3 less than 11. Three plus 7 is equal to 10. 4 less than 10. Three plus 4 is equal to 7. 7 is equal to 7. Here, the sum of the two sides is equal to the third side. So, the triangle is not possible with these measurements. Two centimeter, 5 centimeter, 6 centimeter. 2 plus 5 is equal to 7. 6 less than 7. 6 plus 5 is equal to 11. 2 less than 11. 6 plus 2 is equal to 8. 5 less than 8. Here, the sum of the two sides is greater than the third side. So, the triangle could be made with these measurements. Now, let us see difference between length of two sides of a triangle. The difference between lengths of any two sides is smaller than the length of the third side. AB minus BC less than AC. AB minus AC less than BC. AC minus BC less than AB. Example: check whether it is possible to make a triangle using these measurements or not. Solution: in the above triangle, 11 minus 9 is equal to 2 less than 14. 14 minus 11 is equal to 3 less than 9. 14 minus 9 is equal to 5 less than 11. Using the concept of sum of two sides and difference of two sides, it is possible to determine the range of length that the third side can take. Points to remember: every triangle has three medians that connect vertices to midpoints, meeting at the centroid for balance and stability. The altitude of a triangle is a line from a vertex that meets the opposite side at a right angle. An exterior angles equal the sum of the two opposite interior angles in a triangle, showing important relationships between angles. The sum of all interior angles in a triangle is always 180 degrees, which help us find missing angle measures. The length of any two sides of a triangle must always be greater than the length of the third side to form a triangle. Thanks for watching.